Hello, students. I just wanted to do a little recap if you were absent about what the activity you missed was. It actually isn't too bad, but just saying, giving more opportunities to look at what we're up to. So the goal of this activity is to apply mathematical patterns to describe how subatomic particles affect the charge and stability of an atom. And so we're going to do some models and we're going to do a little bit of math, but usually it's going to be very pictorial, which means we're going to be visualizing the atom. So, just want to give an overview that scientists answer big questions through a process. So usually we have a wild guess, we find a pattern, we make sense of the pattern, and then we make predictions about other problems because that's how we apply what we learn at the very beginning. So, when I first introduced myself, I gave myself a story about as a child, I ate tamales in El Salvador or from El Salvador. And to reheat them, I would put them in a microwave. And I quickly learned that um you should not be putting tamales in the microwave because it'll make a weird noise. Another time, I put a metal fork and the same thing happened. So then I learned don't put stuff in the microwave. And then I learned that maybe all metals have a property that go into microwaves that change. So for this activity, we're going to be talking about cobalt 60. So cobalt 60 is an element used to treat brain cancer. In your notes, you can follow along in a document that looks like this. Cobalt 60 is used to treat cancer. We're going to be talking about what does 60 mean, but it has 27 protons and 33 neutrons to add up to the number 60. And so I'm asking you, using this information, is cobalt 60 is radioactive or is not radioactive? Um, all right. And you can ask more questions about why do we need to know what makes things radioactive. So we'll be using a simulation called Build an Atom. If you check your Canvas page, there's a link to it, or you can just Google Build an Atom FET, Build an Atom FET, click on it, and then you have three options. First, you're going to click on the atom, and if you follow your checklist, you should select atom, open it, and then click on net charge and mass number. So net charge and mass number to reveal the cartoons. And then lastly, you should be finding show, and then see if it's stable or unstable. And you should be answering some questions in the student guide, like how do you change the element? How can you change the mass number? How can you change the net charge? How can you get a neutral atom? And when does the atom become stable? So what you can do is you can start just playing around, putting your tamale in the microwave. So right now you can see that I just have a neutron and it's shaking. Huh. I added a red thing called a proton. It's stable and it has a name called hydrogen. It also tells me that it is an ion. If I keep adding more protons, oh, it changed the name. So now that's an example of how to change the name. I added a proton. And you should be able to do this for all things, like what is a neutral atom? That's still positive ion. Okay, that's a neutral atom. Perfect. So I'd like you to answer these questions. The next step is to refresh the FET, and that's what I'll do. And this time, click Symbol. And I want you to be able to label what this diagram is showing you. What are these numbers are supposed to mean? So fill in the blanks right here. Once you finish this step, we're ready to now actually design an experiment. So every experiment has a research question. And the research question is here in the blanks for you to fill in. If you're doing the digital version, you have to double click it and write in the text. So we need to design an experiment where we have to identify an independent variable to find a dependent variable. So what subatomic particle are we going to change? The protons, the neutrons, and electrons that affect stability. If you need help writing this research question by picking the correct one, I'd prefer to use question 5 to help write your research question. Great. So step 2 is that now you'll be collecting data. So I will assign you to a group. So some students will be making a neutral charge, which means 0. Some students will be making a positive charge, which is +1. Some students will be making a negative charge, which is -1. And so here are some examples of what that should look like in the cartoon. And so now you can access this Google Drive and find what you're supposed to be making. So if you look at the bottom, it says group 1, group 2, group 3, group 4. And you have a chart partially filled in. So for example, I need to make hydrogen. I need to make sure, and I'm making a neutral atom. I need to make sure it has 1 proton and 1 electron. So I'll do that just that. I have 1 proton and 1 electron. Now, I notice I don't have any neutrons. Right now, it says it's stable, so this is acceptable. So I can say 0 neutrons, and I can record the mass number is just 1. We can make another version of hydrogen. So this time I'm going to add a neutron. Okay, cool. So now I can add 1 neutron, and the mass number is 2. And then we can keep doing this. So helium, we can make helium. So I'll add 2 protons to make helium. And I need to put 2 electrons because that's what it says here to do. And then add another another neutron. And so now the mass number is 4. And so the mass number of this, oh, sorry, my bad. 2 neutrons. I have 2 neutrons, so the mass number is 4. Easy mistakes. And then I want to see where this breaks down. So I actually was curious. Okay, you can have 3 neutrons. You can have 4 neutrons. You can have, wow, that's a lot of neutrons. 5, 6. It's not breaking. 7. Wait. Oh, what? It's because I didn't have stable, unstable. So this is quite unstable. So make sure that you always have stable, unstable clicked off in your activity. I forgot to do that when I refreshed mine. So make sure that you're putting in, so it cannot have 3, but it can have 1 neutron. So I'll say another data point. It has 1 neutron, and then the mass number is 3. I also can tell that 2 plus 1 is equal to 3. That's another way we can calculate it. And at this point, you can start seeing your data get onto this graph, and we'll get an equation. So as you fill your elements from 0 to 10, your equation's going to change. This is what you'll record for question number 3. We'll discuss question number 4 in class, but just wanted you to consider that there are a lot of patterns that are mathematical in chemistry. All right, good luck, students, with this. Oh, last thing. How to answer question 6. To confirm your prediction, you can go to Canvas, and by the time you're watching this video, there will be a in modules you can see there is task 2 additional information about cobalt, and you can check to see if cobalt-60 is radioactive or not radioactive by using the stability chart and typing in cobalt-60. And I won't do that for you, but I just wanted you to be able to confirm your hypothesis. All right, have a good one. Bye-bye.